Acha. Acha, should we start? Acha, talking about chemical bonding, we have to discuss today. Chemical bonding, सबसे पहले we have to understand why do particles need to bond. What do you think? Particles bond क्यों करते हैं? जी ज़ोहेब. To fill their shell, right? And as a result, compounds are formed. You, Zohaib, you're right. Zakir, you're right as well. But why do they have to fill their shell? Like, what difference does it? It becomes stable. Very important. And if I go one question ahead, what do we mean by stable? G, Afan, yes. Statement wise, you're right. Like, if we talk about if an atom has complete shell, then it is stable. But what do we mean technically by stability? Balance, anything else? Chemistry mein, what do we mean by stable? G. Unreactive. That is important. Yes. Neutral. It actually, in terms of energy, if we talk about stability in higher classes, is always linked with energy. Whenever we say a compound or a substance or a particle has become stable, it means the energy has been lowered. Okay, low energy substances are stable, they are neutral, they are unreactive, as you mentioned, and they achieve that if their outermost shell is complete. Because if their outermost shell is not complete, they are unstable, they'll just move around, they'll have a lot of energy. Okay? But the energy aspect, the energy calculation, they are all discussed in higher classes. Okay? For now, if you say these words, they are completely fine. But just to give you an idea, just to give you a hands up, stability always refers to energy value. So anything that is stable means it has less energy. Okay? It will not move around. It will be, as you mentioned, neutral. Fine. So anyway, if particles do not have their outermost shell complete, then it's a clear indication that it has high energy, which means it will be unstable and it will be reactive. Okay. So anyway, we'll continue with the topic now. So chemical bonding refers to an attractive force that exists between atoms or ions. We'll talk about what types of bonding, how do these particles gain stability. We'll talk about that in a while. Now, as you mentioned, the main objective is to complete their outermost shell. But just generally being a chemistry student, you should have stability and energy value at the back of your mind. Okay? This is a very tip of the main concept that they have to complete their outermost shell. But the main objective is to gain stability. Okay? So if an outermost shell is complete, it stabilizes an atom. Why does it stabilize? We do have reasons. Again, we'll discuss that in higher classes. So there are two ways to achieve stability. Either they have to transfer or they have to share electrons. Okay? So we have specific bonding in which electrons are transferred, and that type of bonding is called ionic. Ionic bonding involves a complete transfer of electrons, whereas if the electrons are being shared, we say that's covalent. Okay? So we'll talk about, then we do have other types of covalent. We have coordinate covalent bond, also known as dative bond, etc. All I'm saying is the story does not end here. There are many, much more detail involved in bonding itself, but we'll just try to understand the two basic types of bond, ionic and covalent. Okay? And we need to practice few examples so that we are able to solve past paper questions. And we'll talk about metallic bond a bit, but that's a very small topic, but mainly we have to differentiate between ionic and covalent. So you can simply identify a substance if it needs bonding or not just by looking at its electronic configuration. If the outermost shell is not complete, it's clearly it has to be completed. If it is having 8 electrons only, then we'll call it a complete shell. So yes, calcium by itself is unstable. It has to bond. So it needs bonding. Argon, if we talk about, it's already stable. So it's called noble gas. Exactly. It's called noble, or it's called inert. Okay. Noble gases they are called inert gases. You're right. Anything else they are called? ये जो last group नजर आ रहा है periodic table में, on the top of this whiteboard there is a periodic table. Helium, neon, argon, krypton, all of them are noble gases. They are called inert. They are unreactive. We have a fourth name as well. What is it? Halogens भी इसको वो ग्रुप 7 को कहते हैं. इसको ग्रुप 0 भी कहा जाता है. ग्रुप 0. ठीक है. So anyway, because they do not basically take part in any reaction, क्योंकि इनके outermost they are already complete, so you will never find a compound of argon or helium, etc. ठीक है. In very trace amounts they were able to make some compounds, कुछ oxides of xenon they were able to make, but such exceptions we will not discuss in detail. Are all exceptions in chemistry. So you need to first understand the basic idea, and then we'll come to the exceptions later on. Like normally, if we talk about metals, they have high melting and boiling point, but then there is mercury, which has lower melting and boiling point. Okay, it is in liquid form. So in chemistry, we do have exceptions, but we need to first understand the main idea, then we'll come to exceptions from time to time. Anyway, oxygen itself, neon, again, stable. This is how you can identify whether an atom needs a bonding or not, just by looking at the outermost shell. Okay? Now we'll start with ionic. How do we properly define an ionic bond? It's a type of bond to do what? Yes, Suhaib. You're right. What happens when an atom loses or gain electron? What does it become? Ion. Very important. So in our definition, we should involve the word ion. So we can describe it as ionic bond is a type of bond that exists between oppositely charged ions. Why are they formed? Because there has been a transfer of electron from metal to non-metal. Okay? मतलब कि if we talk about, for example, if you want to understand this in detail, we'll go for a very basic example, that is NaCl. So initially sodium, let me represent the sodium with dot and chlorine with cross. If you look at sodium, it is in group 1, and since only the last shell is involved, last shell को क्या कहते हैं? Valence shell. Since only valence shell are involved, we do not have to draw all the shells. In dot and cross diagrams, sometimes it's mentioned, sometimes it's not. But remember, you just have to show the outermost shell. Do not draw the inner shells because they're not involved in the bonding anyway. So since it is in group 1, because periodic table will always be given to you during exams, so you can always refer to the periodic table. Sodium is in group 1, so it will have 1 electron. Okay? If you talk about chlorine in periodic table, it is in group 7, so we'll show 7 electrons, right? One more, 7 electrons. Now what will happen? Yes. Yes, why not sodium gain 7 electron? Why not chlorine loses 7? Yes, less energy. It's easier. Rather than sodium gaining all 7 electrons to compete, it's easier to lose an electron. So what will happen? Sodium will lose an electron and it will be gained by chlorine, which means the sodium will have now inner shell as it becomes more visible. The inner shell is now visible. Sodium पे which charge will it have, Rafi? Positive. Positive. Yes. And chlorine will it will be negative, right? So you have to show that one of the dot is now in the valence shell of chlorine. But if you leave it as it is, you lose a mark. What is missing? The charges. We have to show the charges or else we'll lose a mark. आपने square bracket के साथ you have to show कि there's a charge of +1 and -1. But what keeps them together? Where is the bond? हम कहते हैं ना ionic bond is the bond कहाँ पे है? What keeps them together? Ions बन गए, so what? So ये तो electrons हैं. Why can't sodium and chlorine just go away? Both are stable. Chlorine will go to the left and sodium to the right. जो online है आप लोग बताएं. Amar, what do you think? Rafe, Susanna? Less energy. So anything that has a dot will be attracted. They both have opposite charges. Universe में there are three main fields in which there is attraction involved. One is gravity. Two masses will attract one another. One is magnetic field. North and south pole will attract one another. The third is electric field. Whenever there is a positive particle and negative particle, if they are formed nearby one another, they cannot just move away from one another. Positive and negative, they have an attractive nature. They attract one another because of opposite charges. Agar सिर्फ stable हो के if charges had no role, then the sodium ion would have gone to the right and chloride on the other side. You get the point? The charges hold them together. Fine. So, and why do charges exist? What holds them together? Some of things are still unanswered in physics. We don't know the nature of charge. We have many questions about gravity. We have many questions about magnetism. We have not yet reached that point to understand charge in full detail. Okay? Because the idea is initially it was part of gravity. During Big Bang, the charges got separated. Another field was formed. But we still have many questions, and we try to observe these distant galaxies. Maybe the answers are somewhere over there when a new star is formed, etc. So just giving you an idea, you're not very sure about the charges, their origin, but in terms of chemistry, it's very clear. Whenever you see opposite charges, they'll attract one another. Fine? You clear it? Opposite, that is why we call it a bond. So bond is not something physical there. It's just the attractive force between positive and negative charge. Okay? G, is it clear? कोई doubt है तो we can discuss. अमार आपका clear है यहाँ पे? अच्छा. If you talk about magnesium oxide, where do we start from? If I want you to use dot and cross diagram to represent magnesium oxide, a very common example again. Magnesium, first of all, what do I have to check from the periodic table? Just the group number is fine. Full, yes, just the valence electron. I don't have to check the complete electronic configuration. So magnesium is in group 2 and oxygen is in group 6. Let me just label it as dot and cross. So magnesium and oxygen, magnesium will lose 2 electrons, right? And oxygen will gain 2 electrons. Now it has a charge of +2 and -2. So compared to NaCl, will it be stronger or weaker? Stronger. It has double the charge on positive and double the charge on negative. It is much stronger than NaCl. That is why we use MgO as inner lining of rocket exhausts. They have magnesium oxide. The tiles are made up of magnesium oxide. It's a ceramic of magnesium oxide and other material, but it has magnesium oxide. Because of +2 and -2, it has a much stronger charge. Similarly, aluminium nitride, not very common, but aluminium is in group 3, which means it will have three valence electron. Nitrogen is in group 5. Okay, so it will have 5 electrons. What will happen? Yes, aluminium will give 3 electrons. Nitrogen will gain 3 electrons. Yes, technically, yeah. But in higher classes, it's not just the charges which determines the strength of ionic bond, it's the distance between ions. So we are ignoring that right now in O levels. So we cannot just say it is definitely going to be stronger, because we have to consider the ionic radius as well. But we discussed that in higher classes. Anyway, dotted and cross diagram, you should be able to draw. Should we move forward? Do you have any question in dot and cross? Acha. Now, we need to look into more examples where the electrons are not balanced. Then what happens? What if we talk about sodium and oxygen? Sodium has to lose one electron, but oxygen needs two electrons. Then what happens? Sharing. So there will be two sodium. Exactly. Okay. Or in case of magnesium fluoride, it happens again. Magnesium is in group 2. It has to lose two electrons, whereas fluorine just needs one electron. So in this case, Mg will never be written as Mgf. It will always be with F2, because one magnesium cannot balance one fluorine. For one magnesium, you will always need two fluorine atoms. Okay? So Mgf is wrong. Mgf2 it's going to be. So the way to write this is you need to draw two fluorine atoms. And if magnesium loses the two electrons, one fluorine will gain an electron and it will have a charge of, fluorine pe kya charge hoga? -1. Either you write 2 over here, even that is acceptable. Or if you want to, for clarity, draw two fluoride ions, you can draw that as well. Okay? You can either just write 2, whatever. Should I move forward? Acha. This is what I was talking about, Na2O. NaO is not possible. Okay? Sodium oxide is always two sodium with one oxygen, because sodium has to lose one electron, but oxygen has to gain two electrons. So for every one oxygen, there should be two sodium. It will have a charge of +1. Oxygen will have a charge of -2. And this is how we write. Okay, is this clear? So we have this question from June 22. What do you think the answer is? D. So P needs how many electrons? Yeah, so there are 6 of them. P needs 2 and Q can donate only 1. So D is the answer. You need 2 of Q. If I represent this with cross, so you need 2 of these Q. Okay? So D is the answer. It was a question from June 22 O levels. Ionic bond may still, if you have any question, we can discuss. Should I move forward? Achha. Now we talk about covalent. What happens in covalent? Sharing of electrons. Okay? So basically, covalent bond is type of bond that exists between two non-metals. That is one way to identify if it's a covalent or not. If I say sulfur trioxide, this is a non-metal and a non-metal, then definitely between sulfur trioxide, there is a covalent bond. Okay? Whenever you have a metal and non-metal, like maybe if you talk about potassium and chlorine, this is metal, this is non-metal, so it will have an ionic bond. Now, we need to understand a specific rule. We'll go for a few examples. So for example, if you have chlorine, it has 7 electrons, and another chlorine also having 7 electrons. How will they go about the sharing of electrons? What will they do? Yeah. Ek dot, ek cross. So what happens? Actually, they overlap. You have to use the word, which is more important in higher classes. We use the word overlap. So their shells overlap, It means the electron of one chlorine and the other chlorine, they enter a region where it's common for both. That region is called region of overlap. So they match one another. The shells submerge into one another, right? Now, there is a rule to be followed, and the rule is number of electron needed will be equal to number of electrons shared. So now the two shells, when they overlap, they have to share an electron. If the left chlorine needs one electron, it will place its own one electron in the center. This is how they go about it. So for example, if we have this region of overlap, right? This is where the two shells, the central point is where the two shells are overlapping. If the left chlorine needs one electron, what will this left chlorine do? It will share one electron, exactly. It will place an electron. So the right side will place an electron and the left side will place one electron. This is how they go about it. So since electrons are not being lost, it is still near them, it will not gain any charge. Okay? So we'll not discuss about charges in covalent compounds or covalent bonding. What about the rest of the electrons? How many electrons are left for each chlorine outside this region? 6. Okay? 7 may 1 has been shared, and remaining, they will give you marks on the basis of counting electrons. They have to make sure have you placed the remaining electrons correctly or not. Okay? इसी तरह the right side will have 6 electrons as well. This is how you draw dot and cross diagram for chlorine. Okay? And one pair is known as a single bond. So this is how you can write, how you can represent the bonding between chlorine. Cl with single line Cl. Is this clear? Acha. If we talk about oxygen, what do you think will happen between two oxygen? Yes, they'll first overlap. There will be a region of overlap. They'll match one another, and then they have to follow the same rule. If the left oxygen needs 2 electrons, it has to place 2 electrons in the center. इसी तरह right oxygen को भी अगर if the right side oxygen or whatever the atom is, it needs 2 electrons, the rule has to be followed. It has to share 2 electrons. Okay? So in this region, what we'll do is there will be total of 4 electrons exactly. Remaining electrons on the left side will be 4. And on the right side 4 as well, and this is called O double bond O. Clear? These are the simplest possible examples that I can come up with. We'll look into more examples. G, should I move forward? Yeah, कोई doubt है तो बता दें. अच्छा. We'll focus on the past paper question. We'll see how what type of question they ask. We'll just go through other examples quickly. Similarly, now you get the idea, right? Nitrogen is in group 5, so it will share group 5. It needs how many electrons? 3. So it will share 3 electrons. Fine. Remaining electrons will be, how many will be left? 2. Total 5 थे, 3 electrons have been shared. बाकी 2 left पे रह गए, 2 right पे. ठीक है? फिर higher classes में we categorize these electrons. We call them lone pair, we call them bonded pair, etc. But not needed over here. And this is how we'll write N triple bond N. Similarly, if we go for H2O, what do you think? So we'll draw initial atoms like this. फिर next क्या करेंगे? Shells overlap. Yes, we have to show an overlap like this. Then what do we do? Share कितना? यहाँ पे how many electrons are we talking about? एक dot, एक cross. You're right. So we'll show a dot and a cross. And what about the other overlap? Dot cross. So for hydrogen, how many electrons are left outside? For hydrogen, 0, none. And in oxygen, then you have 4 electrons. And this is how you show water molecule. So it's H2O, reason being oxygen needs 2 electrons and hydrogen needs 1. Bilkul Susanna, you're right as well. I'll move forward with other examples. Carbon dioxide, if we talk about, how do we do this? Overlap में center में कौन सा होगा, oxygen or carbon? Center will be carbon, it needs more electrons. So you draw overlap first. This is how you go about it. Then what next? Oxygen will donate or will share how many electrons in the center? 2. And how many electrons will be left for oxygen? For oxygen? 4. And in the other oxygen? 4. What about carbon? 0. Since there are no charges on carbon and oxygen, what keeps them together? What do you think? Ionic का तो मैंने बता दिया. What keeps a covalent bond together? Because bond is not, it is not something sharing of electron, but the overlap. Yeah, you're there almost. Yeah. What about nucleus? Almost there. What keeps covalent bond intact? Why don't they just go away? What holds them together? The electrons and the nucleus. So basically, this electrons have a charge, right? What charge do they have? Negative. So this region is negatively charged. What about these nuclei? Nucleus has protons. They are positive charge. And this is also positive. So positive, negative attract. Will not use the word ions, but the charges still exist. And this, in this case, the charges are between electron, are on electron and protons, nucleus. So there's an attraction between these two. There's an attraction between these two. This is the reason a covalent molecule will not just split away. Rather, it's strongly bonded between electrons and the nucleus. The electrons are being shared, which means it is being attracted by both the nuclei. It's being attracted on the left and right hand side. That is why a bond will never split. Fine. Until unless it has a tremendous amount of energy provided. But anyway, this is how we write. Similarly, now I think you get the idea. NH3 will draw the overlap first between nitrogen and hydrogen. How many electrons? Yes, single bond. Is there any electrons left? 1 where? 2. 2 left in nitrogen. Okay, and this is how we draw them. What about HCl? We'll go for an overlap. Remaining electrons will be 6 of chlorine. Okay. CH4, one more example, overlap of central carbon has 4 hydrogen around it. There's an overlap. We'll fill the electrons. Is there anything else left? No, so this diagram is complete and this is how we draw. This is how we represent in O levels. In higher classes, we have a completely different way to represent CH4. In A levels, we draw CH4 like this. We draw a 3-dimensional view. This is how you draw. It shows it's in 3D, but anyway, we'll talk about that later on. Coming back to a few questions, it's a question from June 22, IGs. Which diagram represents the outer shell electron in nitrogen molecule? What do we mean by nitrogen molecule? It is 2 nitrogen, it's N2 actually. So which option do you think is correct? Nitrogen is in group 5, just to give you an idea. B. yes, because nitrogen is in group 5, so it needs 3 electrons. It will share 3 electrons, remaining will be 2. These are some common examples. Yes, Samar, you're right. So we have to go for option D. They did not draw the circles, but you get the idea, right? What about this one, June 22? This is an O levels question. Which dot and cross diagram represents carbon dioxide? C. Okay. We have discussed this example. You can go back to the notes. You will not be able to completely answer this because we have not yet discussed the properties of ionic and covalent. So what we can do is ignore C and D. You just have to tell me, is A and B, are they true or false? Both of them. False, how can you say? Each molecule has 16 pair of electrons. How did you count? In total, how many pairs of electrons do we have? They are talking about in total. 2 pairs. Nine. Each molecule of SiF4 has exactly 16 pair of electrons. Is it true or not? True. Why? If you talk about silicon, in the periodic table, silicon is 14. If I count total number of electrons in SiF4, right? Silicon has 14 electrons because it has a proton number of 14. Silicon is right before the phosphorus. If you talk about fluorine, fluorine has a total of 9. It has a proton number of 9. How many fluorine does it have? SiF4 में कितने fluorine? SiF4 में 4 fluorine. ठीक है, काफी. 9 into 4, what do we get? 36 plus 14 is 50. There are total of 50 electrons in SiF4, which means how many pairs? 25 pairs. They have mentioned 16. This is how you do it. A is wrong. Is this correct? Is this clear? You have to, because you need to look at the sentence. Each molecule, they didn't say the outermost shell or anything, or the shared electrons are 16, etc. They just mentioned a complete molecule of SiF4 has 16 pair. Well, we calculated there are 25 pairs. The total shell, the total number of electrons, because they didn't mention about in outer shell or anything, right? In SiF4, both silicon and fluorine have the same electronic configuration as neon. Neon has a total of 10 electrons. Well, this cannot be true because silicon already has 14 electrons. Silicon is supposed to be like this, 284, whereas neon is just 28. They cannot match. Neon and silicon का match नहीं आ रहा. ठीक है, silicon is 284 whereas neon is 28. So B is not true. Whether C or D is correct, we need to first go through the properties. Only then you'll be able to answer. वैसे इसका answer is D, but we have not yet discussed the properties. That's our next topic. ठीक है? So before we discuss properties, one more MCQ. Which do you think is correct? A is correct. ठीक है? The reason C is incorrect because oxygen has 6 electrons. This is wrong. Hydrogen only has 1 electron. This is wrong. C2H4 has, there's a pair missing, which we'll discuss later on. C2H4 has a bonding like this. So there's a double bond between two carbon, but anyway, A is correct. We'll talk about properties in the next class. We should be able to finish. Major questions come from the properties, not the dot and cross diagram. So we need to understand the properties in detail. We'll continue tomorrow.